Think you know how the world works? These insane physics and chemistry facts will make you rethink everything. Welcome to Tell Me Why, where we uncover the craziest, most fascinating physics and chemistry wonders you never knew. Tell me why some materials conduct electricity while others don't. Have you ever wondered why some materials like metals are great at conducting electricity, while others like rubber seem to stop it in its tracks? It all boils down to electrons. Conductors have free electrons bouncing around. Think of it like a crowded hallway. When electricity comes along, those electrons can easily bump and jostle each other, carrying the electrical charge along with them. But insulators, they're different. Their electrons are more like those kids in school glued to their chairs, stuck in place. That's why we use insulators to protect ourselves from electrical shocks, like the rubber coating around those wires you see every day. Tell me why boiling water bubbles? Have you ever watched a pot of water boil and wondered what was going on inside those dancing, bubbling depths? When we crank up the heat, we're giving those water molecules a serious case of the jitters. They start vibrating faster and faster, bumping into each other with more and more energy. Now, water molecules love to stick together. They're like the best of friends. But when they get enough energy from the heat, they're like, see you later, and turn into a gas called steam. It's like going from an orderly line of people to a wild, arm-waving dance party. So those steamy water molecules need more room to boogie, and they push their way up, forming bubbles that rise to the surface. That, my friends, is the science behind those mesmerizing boiling bubbles. Tell me why chemical reactions release heat. Ever noticed how some chemical reactions, like lighting a match, really heat things up? That's because chemical bonds, those tiny forces holding atoms together, are like little storehouses of energy. And when those bonds break and new ones form, well, that energy has to go somewhere. Sometimes it's released as heat, and things get toasty. Think about burning wood. Inside that wood are complex molecules held together by chemical bonds. When we add heat like striking a match, we give those molecules enough energy to break their bonds. And as they break apart and react with oxygen in the air, new bonds form, releasing energy in the form of heat and light, creating that cozy campfire glow. Rusting is another example, though it happens much, much slower. Iron reacts with oxygen in the air, forming iron oxide, aka rust. Tell me why glow-in-the-dark objects work. Ever wondered how those glow-in-the-dark stars manage to light up your room long after the lights go out? The secret lies in special materials called phosphors. These clever substances can absorb light energy and then slowly release it over time, creating that eerie, awesome glow. When you expose a glow-in-the-dark object to light, those phosphors are hard at work, absorbing those light particles like a sponge soaking up water. Then, when the lights go out, the phosphors slowly release that stored energy as light, creating that cool glow. Some phosphors release their energy quickly, giving off a bright but short-lived glow, while others take their sweet time, emitting a fainter but longer-lasting glow. Tell me why a mirror flips left and right, but not up and down. Mirrors, those shiny surfaces we encounter every day, seem like magical portals reflecting our images back at us. But the science behind these reflections is actually pretty straightforward. You see, light travels in straight lines. When those light rays bounce off a smooth surface like a mirror, they bounce off at the same angle they hit, like a perfectly thrown bounce pass. Now here's where things get interesting. Our brains interpret those reflected light rays as if they had traveled in a straight line from behind the mirror. It's like our brains are drawing an imaginary line from our eyes to the mirror, and then extending it behind the mirror to create a virtual image. And because of the way light bounces off the mirror, this virtual image appears flipped horizontally. Tell me why lightning is hotter than the sun? Lightning, those electrifying streaks across the sky, are a force to be reckoned with. But did you know that a single bolt of lightning can reach temperatures 5 times hotter than the surface of the sun? That's right, around 30,000 degrees Celsius or 54,000 degrees Fahrenheit. Thunderclouds are like giant electrostatic generators, with positive charges at the top and negative charges at the bottom. When the electrical potential difference between the cloud and the ground gets large enough, zap! A massive surge of electrons flows through the air, creating a lightning bolt. This surge of electrons is so powerful that it rips apart the air molecules in its path, creating a superheated channel of plasma. Tell me why a dropped coin makes different sounds in water and air. Ever noticed how sounds change underwater? Drop a coin in a pool, and it sounds different than dropping it on the pavement. That's because sound waves, those vibrations that travel through a medium like air or water, behave differently depending on the density of the medium. In air, those molecules are spread far apart, so sound waves have to travel a bit farther between collisions. But in water, those molecules are packed much closer together, so sound waves can zip through much faster. Water is also much denser than air, meaning it's harder to squeeze and compress. This density allows sound waves to retain their energy and travel greater distances without losing much intensity. Tell me why salt dissolves in water. We've all seen it. Sprinkle salt into a glass of water, give it a stir, and poof! The salt seems to vanish. But fear not, the salt hasn't disappeared entirely, it's just undergone a remarkable transformation called dissolving. Water molecules are like tiny magnets, with a positive end and a negative end. And salt, it's made up of positively charged sodium ions and negatively charged chloride ions, all neatly arranged in a crystal lattice. When salt meets water, those water molecules get all excited. The positive ends of the water molecules gang up on the negative chloride ions, while the negative ends of the water molecules surround the positive sodium ions. This tug-of-war weakens the bonds holding the salt crystal together, and eventually, the water molecules pry the ions apart, surrounding each ion in a cozy sphere of water molecules. Tell me why airplanes can fly. Have you ever looked up at a giant airplane soaring through the sky and wondered, how on earth does that thing stay up there? The secret to airplane flight lies in the ingenious design of their wings, and a little help from our friend, air pressure. Airplane wings are specially shaped with a curved upper surface and a flatter lower surface. This shape, called an airfoil, is crucial for generating lift, the upward force that counteracts gravity and keeps planes aloft. As the plane moves forward, air flows over both the upper and lower surfaces of the wing. To meet up at the back of the wing, the air flowing over the top has to move faster, creating an area of lower pressure above the wing. Tell me why your voice sounds different in a recording. Have you ever recorded your voice and cringed at the playback thinking, do I really sound like that? Don't worry, you're not alone. Most people find their recorded voice a bit jarring, and there's a perfectly good scientific explanation for this phenomenon. When you speak, you hear your voice in two ways, through air conduction and bone conduction. Air conduction is the most familiar way we hear sound, where sound waves travel through the air and vibrate our eardrums. But our own voices also travel internally, vibrating the bones in our skull and reaching our inner ear directly. This bone conduction pathway emphasizes the lower frequencies of our voice, making it sound richer and fuller to ourselves. However, when we record our voice, the microphone only picks up the sound waves traveling through the air. Thanks for watching. If you enjoyed unraveling these scientific mysteries, don't forget to like, subscribe, and hit the bell icon for more mind-blowing science content. Stay curious.